Welcome to our viewers. Thank you for joining our fireside chat today discussing object storage for media and what you need to ask. Joining us today is Erik Weaver. Welcome, Erik.
Hi, thanks so much, Jennifer. I'm Erik Weaver. I work for the ETC. The ETC is a nonprofit think tank that's founded by the CTOs of the 6 major studios. So we look at what's coming around the corner and what's really important. And object storage is absolutely important right now for your roadmap. So I've got a great guest here today, David Phillips. David, you want to introduce yourself?
Thanks, Erik. So I'm David Phillips, Principal Architect for Media and Entertainment Solutions at Cloudian. So the key function of my role is to help organizations who are looking to integrate object storage into their existing media workflows, or sometimes they're at that transition point where they're looking to move to a next generation solution. Prior to joining Cloudian, my work over the past 20 years has primarily been on the customer side, focused on designing and deploying infrastructures for everything from feature film mastering to broadcast studio post-production. I try to leverage that experience in understanding customer problems and working with them to design, workflow storage solutions.
Awesome, thanks. And this topic's really near and dear to my heart because I've worked in the field of cloud so long, and I also ran global strategy at Western Digital, where this was a daily thing we dealt with. Dave, let's just jump right into this. Let's talk about it. What is the difference between block or file storage versus object storage?
Yeah, it's a good question, and it's even though object storage is fairly mature at this point, in the market, I think there's still some confusion on how exactly object storage is different and how exactly it works, as a storage platform. So I think it's helpful to look at the diagram of when we talk about storage types. So when I look at a chart like this, I see distinct points on the continuing evolution of data storage. So scanning from left to right, I see block storage as the oldest technology, but even so, today is still considered the fastest type of storage with the lowest latency because it provides a direct connection to the physical storage device, be it spinning disk or flash-based devices. Quite often is still the most expensive type of data storage on a cost per gigabyte basis, especially those flash-based systems, but customers, who need the highest performance, especially for structured data like databases, where they need that kind of, business critical, high performance. That's the investment. That's what they're investing in. So moving across, to file storage, also, referred to as network file servers or NAS, network attached storage. So net file storage differs from block in that by design, it overlays a level of logical abstraction. It takes a collection of block storage devices, stripes them together using some form of RAID technology to provide data protection and increased performance. And then it presents this logical storage volume as a shared network mount point for servers and end users to access. At their core, file servers utilize some sort of hierarchical file system or file system tree that provides the benefit of a very human-readable method of organizing files, very much like a digital version of an office filing cabinet, with a series of drawers that contain folders and documents. But there's downsides with this method of storing data, just like that physical filing cabinet, where there are only so many pieces of paper that you can stuff into it. There are limitations to the number of files that a file server can reasonably manage. And this varies by vendor, but generally speaking, this limit is in the range of 1 million files. As the file server approaches this upper limit, the file system database that holds the file lookup tables becomes so large that the CPU of the file server becomes overwhelmed with processing queries from clients. At this point, just like that office filing cabinet, the only option for expanding capacity is typically to buy another filer, which then introduces data management issues. Which filing cabinet contains the file that I'm looking for? Which volume did my colleague put that file on? So as we move across to object storage, from a high level, object storage is similar to other scale out or clustered file system technologies. in that you have a certain number of storage servers acting together in a coordinated manner to provide a storage repository for writing and reading data. But there's a number of key differences between, kind of legacy file and block storage solutions. One is that object storage adapts a service-oriented approach for its storage interface, with the S3 API being far and away the most common protocol. Key thing to note here is that, like other web service APIs, object storage APIs are inherently designed to be accessed over a wide area networks and are much more tolerant of the high latency network connections than traditional network file server protocols. So, NFS or SMB, if they don't get a kind of acknowledgement, in a very short time frame, then they kind of time out and potentially even drop their connection. Another key difference is that object storage platforms address the issue of scaling by doing away with the hierarchical file system approach in favor of a flat address space that utilizes universally unique identifiers.
Awesome. So you mentioned RAID and the opposite of that for object storage, which is erasure coding. Can you talk a little bit more about how those systems vary?
Yeah, exactly. So, be it a block storage SAN or a file storage NAS platform, typically is using some sort of underlying RAID technology and a redundant array of independent disks that are striped across a group of those disks in order to provide performance and data protection. So typically, you can, in the case of RAID 5, you can sustain one drive failure. In the case of RAID 6, you can, sustain, 2 drive failures and still have access to your data. The real issue with RAID technologies is that it's very tied to the physical devices themselves. So in the case of, a high capacity spinning disk, be it, 14 terabytes, 16 terabytes, if you get a failed high capacity disk and you have to replace that device, you have to rewrite every sector of that disk, of which there are tens of millions of sectors, for these high capacity hard drives, it can take 48 to 72 hours. Even if during that time you're actually vulnerable to a second device failure. So it's really kind of it has inherent physical limitations. So with erasure coding, uses a similar concept of, striping data fragments across a group of storage, storage locations. But it, again, like object storage, it abstracts that up to another level where instead of striping across physical hard drives, I'm striping these data fragments across nodes in my storage cluster. So I'm not only protected against hard drive failures, but I can have an entire node or an entire chassis fail and still have access to my data, and my data is still protected. And we can take a closer look at that in a second. But in a nutshell, it's the reason that object storage was really developed was to try to address the scale limits of traditional block and file storage. And the modern kind of web scale platforms, be it Facebook, Amazon, Google, etc., really would not be able to scale to the millions of users and billions of files that they have under their control without having this kind of web scale object storage platforms as their kind of back end.
So I got to say, I have actually seen that difference there. So instead of having to drive out right away, I've seen people with object storage where they just schedule a quarterly meeting for someone to come in, look for bad drives, pull them out and replace them. It's a pretty big difference actually in the amount of labor intensity and other issues you got to deal with. So let's talk a little bit more about durability. So are you saying that object storage is a lot more durable and reaches a higher level of nines or other formats of durability?
Yeah, absolutely. I mean, there's, when you're striping across, not only like multiple kind of storage nodes, but across, the idea of data centers and different availability zones or regions, you kind of create, a much higher level. But I think it might help to take a closer look at exactly, how does an object storage platform, how does it operate? How does it store data, and how does it serve data out? And then how does it protect that data, as you're saying? So all object storage platforms are, a little bit different, but from a high level, they're similar to, to a diagram that looks like this, right? So in this diagram, we have a cluster of 12 storage nodes. They're all running a distributed database service that synchronizes all the cluster information and storage metadata between each of the nodes. Because each node has a synchronized database index of all the objects stored in the cluster, each node can serve storage requests independently. The API calls to the object storage cluster are routed through a load balancer. The load balancer serves the dual function of routing around failures in the cluster in order to provide high availability, as well as distributing storage service requests to the individual nodes for maximum aggregate performance. So all of these backend services are presented to the network as a storage domain URL, much like a website, with top-level storage containers called buckets. So, there's, instead of this idea of I've got, a storage volume, I've got this concept of a storage domain that's abstracted from the underlying storage servers that, essentially are storing data and serving data from that domain. So when files are written to the storage domain, a host of metadata values are assigned to the object, with the source file name recorded as the metadata value of the, that's the object key, as far as the metadata value for that object. So as that file comes in, that file name, that object key, is hashed into a unique ID, right? So in order to retain the human readable benefits, though, of a hierarchical file system, the objects can be organized under the top level bucket with metadata values called prefixes. And on a bucket listed operation, these resemble a traditional file path with folders and subfolders, but it's really just metadata. They're just virtual constructs. So if we look at our, file, essentially our URL here, we have our storage domain and our top level bucket of assets. And then, as an organizational prefix, I've got, it's separated into shows and, individual shows, and then seasons of that show, and then finally down to a single episode object of that show, a video file that represents that episode. So in this case, the full URL, that's a unique URL for that storage object in this storage domain. So at the lowest level of the storage cluster database, each object is assigned a universally unique ID, based on a hash of the file name. So when we talk about a flat address space versus hierarchical file system, this UUID is really what makes this possible. Because this UUID is assigned, typically as a 128-bit alphanumeric value, the number of addressable objects in practical terms is infinite. So every storage, object storage platform is a little different, but this is the kind of scale that's required in order to have a flat address space that essentially extends, forever. You can think of object storage in a way like a car valet, right? So when you check in your car, the valet may write red Honda Accord on the ticket, but the ticket itself has a unique ID printed on it, and that goes with your keys into the bin. So when you go to pick up your car, from this valet lot that has an infinite number of parking spaces, you hand the valet your ticket, and then he reads the ID on the ticket, finds your key and matches it with the key, and then your car is delivered back to you. So, it's kind of a, very rough analogy, but it's just a kind of highlights the difference between, object storage as a service, as a storage service versus file systems and block storage where you're interacting, more directly with the data. So to your question about, how is data protected across this storage domain? Well, object storage typically has, two primary, means of data protection, two storage policies that you can assign to a bucket. The first is replicas, where as an object is written into the storage domain, the system then goes and makes two more copies of that object across independent nodes in the storage cluster. So in this way, you can essentially survive, the failure of two whole independent nodes or two disks that hold fragments for that object, and still have access to your data. It's still protected. When those failed devices are replaced, then the system takes care of repopulating those objects across the new hardware, be it disks or be it entire nodes or chassis. So similar to RAID technologies, the object storage platforms utilize something called erasure coding, which is very similar to RAID technology, in that I'm taking a large file, I'm breaking it up into fragments, and then I'm distributing those fragments across storage devices. In this case, they're entire storage server nodes. And then I'm creating additional parity fragments of those from those data fragments that I can rebuild data fragments in the case of a catastrophic failure. So, and unlike RAID technology, which typically kind of maxes out at, say, RAID 6, where you have two parity drives for every, for every, let's say, 6 data drives. Erasure coding can scale to much greater levels of data protection. In this example, we have 12 nodes, and we're using a 9+3 data protection erasure coding scheme. But this can scale to things like much higher levels, like 12+4, or 16+8. So it's really just a logical storage policy of like, okay, as data is written, protect the data by distributing fragments, this many fragments across the storage devices. Now, so when you have the catastrophic failure, like I was saying, the load balancer comes into play, and if it's not getting a heartbeat from that storage server or storage servers, the nodes, it just routes around the failure to the next available node that has those data fragments. So then in this way, it's inherently designed to withstand and route around failure. That's the way that these web scale companies like Google and Amazon are able to store and protect the massive amounts of data in their data centers, because as you can imagine, on a daily basis they have a host of device and equipment failures, and that's the expected. They've designed their systems to route around those failures. So it's a whole order of magnitude greater means of data protection, right? So, and that includes not only protecting data in a single data center with things like erasure coding and replicas, but I can actually extend that scale of data protection across a geographically distributed domain, right? So if we take an example where I've got a 12-node cluster, this is my private storage domain in a data center. I have a large file. This is a sporting events recording. As that, I want to write that file to store and protect it on my storage cluster. It's assigned a unique URL. And then erasure coding storage policy takes and breaks that large file up into smaller data fragments, and then distributes those fragments across the nodes of my cluster. So let's say my data center is in Los Angeles. So if I have additional data centers in Colorado and New York, and they're all essentially on the same, or be able to communicate on the same network, I can replicate all of those data fragments from Los Angeles to Denver, and even Denver to New York, so that I have really, a level of data availability and data protection that's not possible with, traditional block and file storages, without, expensive and, cumbersome sync operations, where I'm trying to constantly sync data between, sync files between sites, which, is possible. It's just object storage is inherently designed for managing the distribution and replication of these data fragments in order to provide data protection. And this idea of replicating data also extends not only from the private cloud, but also to the public cloud, where I can make a copy of my object and tier it off to Amazon, Google, Azure, and I have even another level of data protection in that it's not only like offsite, it's not on my network, and it's on a hosted managed service.
Excellent. Thanks, David. Can you go into how then does this fit into my workflows or my media entertainment environment?
Right. So, and that's, often the kind of, for customers who they've heard of object storage or they're already using some sort of managed cloud service, they still don't quite understand, like how does object storage, in my data center work? And so, if we look at a legacy, data media storage infrastructure, you might have a diagram something like this, where remote teams, field productions are going out, they're shooting, acquiring content, and then they're in some way trying to get that content back to the central data center for long-term preservation and further, media processing, media editing, media, distribution. So, it's even today, it's not uncommon to have shooters offload their camera cards to a USB hard drive and then put that in a FedEx envelope and ship it back to headquarters for ingest into the central data center. So, or they're laying that off to make it a backup to an LTO tape and then shipping that physical media. So, there's obviously lots of file transfer solutions like Aspera, Signiant, File Catalyst, but this is the kind of situation you're looking at. Is I've got a central block storage or SAN or NAS file server, and then I'm further backing up those files from my NAS onto some sort of, most typically an LTO tape library for further backup and long-term preservation. So when you shift to the concept of I need a scalable storage repository to store all of my media content, my media library, and this could be even including my legacy media library that ranges in the tens of petabytes. News and sports organizations that have legacy footage archives. You really start to see that I'm kind of flipping the whole model on its head, right? Instead of I'm going to migrate to my high performance storage and then back that up, what you're starting to see is organizations, it's like, here's my valuable footage. I've spent a lot of money, hiring crews and talent to acquire this out in the field or on productions. I need to store and protect this immediately as soon as possible. So it's really starting, when people talk about a cloud first, you can almost think of it as like, let's get it onto object first, and so that we can know that it's protected, and then we can kind of move it around and place it as it needs to go through the rest of our media processing pipeline, be it transcoding, editing, or distribution.
That's one of the biggest changes I've seen in the industry, how it is flipping like this, where landing exactly like you're saying here to an object storage and then being served out or checked out like a library to either your faster storage tiers or onto an LTO library. So let's go ahead and dig just a little bit deeper into use cases. Can I use object storage for video editing?
Right. So, and that's also a common question. As we're kind of talking through here, we're really thinking in terms of object storage being a secondary storage tier. I've got my primary storage, that's high performance tier 1, be it, oftentimes flash based, be it SAN or NAS, that really has the kind of high throughput for both ingest and, like a real-time play out and, where I can do transcode dailies as fast as possible. So, the question is, once you start to replace, now I've replaced my LTO library with an object storage, cluster, so that I can have an active archive. I can get a faster archive speed to archive and faster speed to retrieve those assets, to my tier 1. I've got all this capacity sitting there. What else can I do with it now? And often the first question is, well, it's like, hey, well, can I edit off of it? And the common response is, well, it depends, and it does depend on a number of factors, like how many users are going to need to edit off of the storage, and what kind of permissions do we need to maintain and segment out, things like that. So it's it is essentially a workflow question and a environment requirements question, and it also depends on if you're talking about this is in an Avid ecosystem, which tends to be a little bit more rigid and rigidly defined as far as what storage devices that it can work with the media composer, and how media moves through that ecosystem. For Adobe workflows that tend to be more open, then it's a little bit more conducive to, hey, I just need to browse my content library, browse and find my clips, and then I want to do some editing and further processing on them. And there's 3 primary methods for accessing for say in the case of a video editing application like Premiere, of accessing my object storage. The first would be accessing a bucket via some sort of NFS or SMB file protocol gateway server that acts as a caching server. It's holds an index of all the objects in the bucket, and then as those objects are requested, and it starts to serve out that data, via file protocol. Second, typical access method would be, I'm going to mount my bucket as a local disk mount on my editing workstation via some drive emulation software that then caches that object data locally. I've got a local SSD on my workstation, and once I cache that data locally, I have very fast random access and real-time play out from that object without having to load the entire bucket of worth of data. And then I think the third primary thing that we see in the in different organizations is typically utilizing some sort of MAM or HSM, hierarchical storage management solution, that takes care of both indexing the primary storage, and it also has an index of all the object storage buckets, my active archive, and then manages the data transfers between the storage tiers and even out to remote users. So, in the current climate, obviously, there's a lot of questions and people scrambling to figure out, how do I continue my content creation workflows, my video editing workflows, while I'm at home and our facility's locked out. And these kind of MAM solutions, be it a kind of private MAM or a hybrid MAM, allows you to kind of browse my content library and then kind of pull the files that I need for my current project.
Awesome. Great explanation there. How about transcoding? Can you transcode media objects with object storage? Yeah,
the answer there is, most definitely. And this, is a moving target. Obviously, there's, traditionally you need some sort of block and file storage. And even today, most transcoders that are accessing object storage will buffer some amount of frames, if not, the entire file in their kind of scratch disk as they're processing, and then they kind of, save out the completed output, transcoded file on the output back to the storage bucket. But in general, as especially as more and more of these applications support the S3 API, which is, by and far and away the industry standard and for object storage API at this point. You find, companies like Telestream Vantage supporting, both AWS and private generic S3 endpoints in their Vantage platform. FFmpeg can directly transcode to and from an S3 bucket, and so a lot of these on-prem applications are supporting S3. But the additional benefit that you get is that because your bucket, your active archive, is exposed, is essentially using this S3 API. Cloud transcoding services like Vantage Cloud Port, and Dolby Hybrid, and all the different ones available on, Amazon, Google, and Azure, can essentially point to your on-prem private S3 URL, just as if it was, up in a hosted managed cloud service. So, we've done a lot of testing and qualification on that. And, you would think like, well, why would you do that? Well, if you're talking about an on-prem content library that ranges, again, in the tens of petabytes, that's, when you think about a concept like data gravity, where data, once you get into the tens of petabytes, even a petabyte, the data is so heavy to lift and, kind of transport and migrate up to the public cloud, that it's really not feasible to just put everything up in the cloud and then operate, be it transcoding, media processing, and the storage cost, that comes with storing petabytes of data up in a public cloud service. So what customers are finding is that, hey, I can essentially like stream, my high-res up to a cloud service and then just download the, let's say the low-res proxy or the AHLS or Dash, streaming, transcoded output from the cloud service. So I can essentially do a kind of cloud bursting model where I've got a certain amount of resources on-prem, but if I have a big job, I can burst that to to the elastic dynamic compute of a cloud service.
So I actually run an archive standards group with some of the studios, and we're always talking 100 petabytes whenever we're talking about the use case. So I completely get, the value of that. So let's kind of conclude with some of the key takeaways that people should walk away with. Can you review those?
Yeah, absolutely. I think, we're talking about object storage from a high level category. And like I say, there's differences between individual platforms and services, but generally speaking, when we're talking about a software defined object storage solution, like Cloudian, you have flexibility in the means of deploying it. You have flexibility. You can start small. It can start as few as, three storage nodes and using a replica-based data protection, and then scale that up to exabyte level. So having that flexibility of how the starting point and scaling up, and also flexibility of the underlying hardware, that I'm going to utilize for that. So, and as we saw with the video editing and the transcoding, having a common S3 API, an industry standard API, allows flexibility where I can have my workflows that can address private on-prem storage, but also those workflows can extend to the public cloud. At the end of the day, though, people are looking for private on-prem object storage, primarily for the aspect of it being a more cost-effective solution. And when you have stored software running on commodity x86 hardware, when you talk about, like I'm storing content over a 5-year or 10-year period, if you do the kind of cost modeling, you really can see that, having a private on-prem solution presents a lower total cost of ownership over the long term. And in addition, using commodity hardware, you don't have the, a software-defined solution doesn't have the vendor lock-in, that comes from, once my hardware ages out and I'm ready to replace it with the next generation hardware, I have choice if, what's the current bang for the buck and price performance, benefits of different vendor solutions. So having that choice and flexible choice and a cost-effective model. But it wouldn't be really, feasible if it wasn't scalable. And, Cloudian, we use the exact same kind of storage architecture designs that AWS S3 is built on, this idea of like, I've got nodes in a cluster in a data center, and those can be, kind of organized logically across a geographic, distributed domain. You can scale out to billions of files and exabyte level of capacity without having to, launch a new kind of storage volume or kind of manage between different storage silos. So having that single global namespace is really, I think, what's most attractive to, organizations who are looking for private on-prem storage. Being able to kind of
and I totally
use both
agree.
the local layer network and the WAN.
Yeah, that private definitely has that cost effectiveness. So it's a very good long-term strategy. So I just want to say thank you so much for giving your time here today. And we are going to run 2 more of these webinars. One going to look into the more into the cost. What is the economics of object storage versus other mechanisms to do things? And finally, looking at abstraction to the point of orchestration. How can you put tools across all of this that really help orchestrate the workflow? So again, thank you so much for your time, David. Appreciate it so much.
Absolutely. Yeah,
And,
thanks, Erik.
I think we have some time for questions. So again, if you, I want to thank, Erik and David, but if you have questions, please enter them in the questions tab at the bottom of your screen. The first question we have is regarding Cloudian specifically. How does Cloudian differ from other object storage vendors?
So, yeah, good question. I mean, I think the primary distinction, that we see is the fact that we have implemented a native implementation of the Amazon S3 API means that we are, really the most compatible S3 compatible solution, as far as private object storage platforms. Like again, platforms are different, but it's a common phenomenon that you have an object storage platform that has a proprietary API that then is translated to other APIs like S3 API, which can introduce like performance and compatibility bottlenecks. I think the other, difference is that, again, as a software-defined storage platform, having flexibility of deployment of hardware profiles, and then also being able to benefit from the cost benefits of using essentially commodity hardware. We primarily sell appliances, which is just we kind of bundle a commodity storage server with our software and present that as a fully supported appliance, and most customers choose that. But there is flexibility if they have HP or Cisco or Lenovo hardware that they are sourcing themselves.
Perfect. We do have another question. The question is, do you have any examples of current customers that you can talk about publicly in the media and entertainment space?
That's always a difficult question because, customers, especially large enterprise customers, tend to be very, be very private, with the vendors that they choose. So there's, I think as far as the customers that we've, dealt with and done kind of case studies and kind of white papers on, WGBH in Boston, I think really early on, is a public television station, but they create, they're kind of the largest creator of, public television content that's syndicated to stations around the country. So they have a very, large production schedule, with lots of different properties that are kind of flowing assets, and they're storing those assets for the long term as they have this, building library. So they really early on, they saw the benefit of private S3 from a cost standpoint, and even just in their case, it was solving a performance issue with LTO tape archive, that their producers really just couldn't get assets back fast enough. Sometimes it took 48 or 72 hours for a request to route through the system, take the tape off the shelf, get it loaded, and get it restored back to their primary storage. So, speed of performance from having a local S3, and also having the, kind of scalability, that they didn't have to kind of keep standing up new storage silos, was kind of drew them to a private S3 storage around Cloudian.
Perfect. And I know we don't have a lot of time left, so this will probably be our last question. And this is from somebody that was just interested in some next steps if they're interested in bringing this to their workflow.
Yeah, absolutely. I mean, reaching out to our, sales teams, we have 2 emails, info@cloudian.com and sales@cloudian.com, that where somebody can kind of field the request and route it appropriately, depending on your location.
Perfect. And with that, I want to thank you both for joining us today. And I want to thank our audience as well. If you have any other questions, please reach out. Again, info@cloudian.com. And we hope to see you at a few of our upcoming webinars. Thank you, guys. Appreciate it.
Thank you.
Thanks, everybody.
Bye-bye.